right, let's look at some continuous compounding examples. So now that we have two different types of interest, we're going to need to know how to tell when to use which one. So let's look at a first example and see if we can decide if this is continuous compounding or if this is just regular compound interest. So it says, suppose $5,000 is invested at an annual rate of 4%, compounded quarterly for 5 years. Find the compound amount. So we notice that this only says compound and doesn't say anything about continuous compounding. So this is just regular compound interest. Okay? So we can start labeling what values it gives us. So our first one that we see is our p-value, which is 5,000. So it is the amount of money that's invested. And we see that our rate is 4%, so our R is equal to 0.04. It's compounded quarterly for 5 years, so our N is equal to 5 times 4. 5 years, 4 times per year. And then we look at our M value, which would be, since it's quarterly, that would be 4. And now we can plug into our equation. So we have our future value is equal to P times 1 plus I to the N. Remember, our I is equal to R divided by M. So when we plug in, we'd have 5,000 times 1 plus R, which is 0.04 over N, or M, as in Mike, divided by 4, to the N, which is 5 times 4, which is 20. So we would have 5,000, oh, that was too many zeros, this is going to be 0.04 divided by 4 would be 0.01, so we'd have 1.01 to the 20. So now we can type this in our calculator, and we'd have 5,000, helps if I do the right number of zeros, 5,000 times 1.01 to the 20, and we get $6,100.95. So this is equal to 6,100.95. And that is our answer for this one. So let's look at the next example. Now this one says find the compounded amount if the interest in the previous example is compounded continuously. How much more interest is earned? So compounded continuously. So let's figure it out. So we have the same values over here. So we still have our P is equal to 5,000. Scroll it down a little bit so you can see. And we have our R is equal to 0.04. And our T, which is up here, would be the years compounded. So we would have 5. Okay, so now we're going to plug into our formula. So we have future values equal P e to the RT. So our P value is 5,000. We have E, our rate is 0.04 times 5. So this is equal to 5,000 E to the 0.02. I feel like that's, 0.04 times, well, I can't type that in, 0.2, so no 0, sorry about that, which we can then type in our calculator. So we have 5,000 second E, 0.2. So we have 6107.01. All right, and we can, the last part it says how much more interest is earned. So this is the amount of interest that is earned when it's been compounded continuously. Now we want to figure out how much more interest is earned when it's compounded continuously versus just regular compound. So I'll just slide this over a little bit. So we want to find the difference of 6107.01 and 6100.95, which is the amount of where it was compounded regularly. So we have this number, which is our compounded continuously, minus our compound. It's equal to $6.06. So the difference, this is more earned. Okay. Next, let's look at the next set of examples. So suppose to settle a debt, you'll be paid $10,000 at the end of 10 years. So what this is saying is, say Matthew owes you $10,000, okay? So you're the one who's getting the money back, okay? So at the end of 10 years, you're supposed to get $10,000 back. If you can get an interest rate of 4% compounded continuously, so again, we see compounded continuously, there's our trigger. What is the present value of $10,000? So our future value is $10,000. And we want to find the p-value. So what else do we know? We know that the rate is 4%, so 0.04. We also know that T is 10 years. And so we can plug in. So we have that 10,000 is equal to P times E, 0.04 times 10. So we have 10,000 equal to P, E to the 0.04. I hope you can see that's 0.4. Okay, now let's divide this E to the 0.4 over. So we get that P, and we can do that in our calculator. 10,000 divided by E to the 0.4, which is $6,703.20 is how much. So right now, in present time, if you invested $6,703.20, and at this rate, then in 10 years you would have $10,000. So the question now that we have to decide on part 2 is, if the person that owes you that money offers you $8,000 immediately to settle his or her debt, should you take the deal? So if they paid you right now, they would just be paid. You wouldn't get anything. You would just get $10,000 at the end of 10 years. Or they're offering you to pay $8,000 right now towards the $10,000. So it wouldn't cover all of it, but it covers some of it. Should you take this deal? Well, yes. Because you can also invest this amount of money yourself. So the reason is because you could invest the $8,000 as in part 1 and make more money. In 10 years.